Alright, welcome to Victor Mark. My name is Victor. Alright, today we're considering the laws of logarithm and how to apply them. So we're going to state some 5 basic laws of logarithm. Now, if you have the first one is law of the multiplication law. So we have log a to base m plus log b to the same base m. Now, technically, it's more or less like we're factorizing the common base. So we're going to have log a will multiply. The addition will change to multiplication, then we multiply with b. So we have a times b with the same common base m. Alright? So technically, it's more or less like we're factorizing the log m, so to say. Alright, number 2 is the division law. We have log a base m minus log b to the same base m. So we're going to have log the first number, which is a, then your minus will change to a division sign followed by b to that same common base m. Now these first two laws, the multiplication law and the division law, is actually applicable this way because we have a common base. If not, we can't use this approach. Alright, the third one is called the transfer of power. The law that has to do with transfer of power. If I have log b raised to power a to base m, I can easily transfer this a to become the coefficient of this log. So to that we're going to have a log b base m. Alright, and then the fourth one is called the logarithm of the same base. If my base is m and I'm dealing with logarithm of that m to that same base m, it's always 1. And then the last one is the logarithm of 1 to non-zero base m. It's always 0. How do I know this? It's very simple. If I have my base to be m, I can write this one as m raised to power 0. The reason why I'm writing it as m raised to power 0 because of my base m. Right? If my base were to be x, I'll write this one as x raised to power 0. So we can transfer this power to the coefficient as we did in the third law we've mentioned here. So we're going to have 0 times log m base m. Don't forget log m base m is also the same thing as 1 from this. So we have 0 times 1, and that's 0. So that's how it's being derived. Okay, now let's see application of these laws. Alright, let's see example 1. Let's say evaluate. We're to evaluate log 7 plus 2 log 2 minus log 280. Alright, now anytime the base is not stated, it's always known that it's base 10. If it is otherwise, it will be stated explicitly. So in this case now we're dealing with base 10, even though it's not specified, it's not written out. Alright, now the first thing here is to transfer this 2 to become the power of 2 by this transfer of power law. Alright, we can move backwards or from right to left or left to right. So in this case now we're moving from this right down to this left. Alright, let's apply it now. So we're going to have log 7, then the 2 become the power of 2 here minus log 280. Now anytime we're dealing with expression like this, logarithmic expression in which the terms are of different signs, it's preferable you arrange all the positive logarithms to come first, then followed by the negative coming last. Okay, now we have here now, it's already arranged. The first two terms are positive, so let's move on. We have log 7 plus 2 squared is 4 minus log 280. Alright, so now by the multiplication law and division law, the log is common of base 10, then this 7 will multiply, the plus will change to multiplication, then 4 followed by the minus, which is going to be division, 280, and then we multiply the numerator. 7 times 4 is 28 over 280. 280 is 1, 2080 is 10. So we have log 1 over 10. Don't forget, we said that we are dealing with base 10. So at this point, I want to write it out. So now, I can write 1 over 10 raised to power 1 as 10 raised to power minus 1. 1 over 10 raised to power 1 is more or less like what we did do in algebra. If we have 1 over x raised to power 1, write it as x raised to power minus 1. So that's the same thing I've done by writing 1 over 10 raised to power 1 here as 10 raised to power minus 1. Alright? Okay? Now, applying the transfer of power, I can transfer minus 1 to the front here, so it becomes minus 1 times log 10 base 10. And don't forget, log 10 base 10 is saying that the law of logarithm of the same base, so we have 1. So minus 1 times 1 is minus 1. Okay, let's see one more example. We have to evaluate log 20 over 9 plus 2 log 6 over 5 minus log 4 over 125. Now the same way, this base is not given, so automatically it's base 10. Alright, now the first thing is to transfer this to become power of 6 over 5. So we have, this is simplified as log 20 over 9 plus 6 over 5. All together, all the fraction, the numerator and denominator will be assigned the power of 2 minus log 4 over 125. Alright, so next now, we're going to expand that bracket. This 6 over 5 raised to power 2. 6 over 5 raised to power 2, 6 squared is 36, and 5 squared is 25, minus log 4 over 125. As I said earlier on in the first example, if our terms are having different signs, positive, negative, try to make sure that all the positive terms comes first. And in this case, the first two logarithmic expressions are positive, only the last one is negative, so we are good. So now, taking the common log to the base 10, but we can still keep the 10 for now, we might not write it for now. Then, open bracket, we have 20 over 9. The plus will change to times, then followed by 36 over 25. Now, the minus will change to division. But instead of using this sign, I would prefer to use this division notation or symbol, for the 4 over 125, so that I can easily change the sign now. So we have log 20 over 9 times 36 over 25. Division change to times, then there will be a swap. 125 becomes the numerator, and then 4 becomes the denominator. Alright, so 9 here, 1, 9 is 36, divides it 4 times, 4 divides 4, 25 is 5 times. So we're going to have, the leftover is 20 times 5. Alright, so it's like we're having this as log 100. Don't forget, we said our base is 10, so let's sign it here. Another way I can write my 100 in terms of a particular power to 10, or a particular power assigned to 10 is 10 raised to power 2, so to base 10. Also applying the transfer of power, the 2 can come forward as a coefficient, so we have 2 times log 10 base 10, and then this is the law of the same base, so we're still having 2 times 1, and then the final answer is 2. Alright, thanks for watching. Please click the subscribe button and share with your friends. Thank you.